There are multiple types of laser beam profilers available on the market today. Two of the principal types available from Ophir Spiricon include those based on 2D sensor array cameras and those based on scanning slits. A camera-based profiler is best when measuring a pulsed laser with a relatively low repetition rate, or the most important measurement is the distribution of power throughout the beam. Scanning slit profilers can make very accurate measurements of beam diameters as small as 5 microns, while cameras are limited to beams greater than 45 microns. This makes applications for focusing lasers or building optical systems much easier with a NanoScan. Because the NanoScan typically does not require optical attenuation, it has very high pointing accuracy, unaffected by additional beam sampling optics. This makes applications requiring precise alignment of the beam in space specifically well adapted to the NanoScan. There are several NanoScan models to choose from. This video will explain how to select the correct NanoScan depending on wavelength, size of the beam, power, and whether the beam is continuous or pulsed. What is the wavelength of the light? There are 3 different detectors available for the NanoScan. Silicon detectors are used over the wavelength range of 190 to 1100 nanometers. A germanium detector used over the range of 700 to 1800 nanometers, and a pyroelectric detector used over the range of 190 nanometers to 100 plus microns. The pyroelectric detector is less sensitive than the semiconductor silicon and germanium detectors. How big is the beam? The beam size determines what slit to use. Due to the slit convolution effect, the slit should be no more than 1/4 of the beam size to generate an accurate beam size measurement within the NanoScan specified tolerance. Ophir offers 2 slit sizes with the NanoScan, a 1.8 micron and 5 micron slit. Thus, if a beam is smaller than 20 microns, the 1.8 micron slit is required to get accurate beam size measurements. The smallest measurable beam within the NanoScan Plus or -3% accuracy tolerance is 7 microns. Otherwise, the 5 micron slit is usually preferred. It's a common misconception that the smaller 1.8 micron slit produces more accurate beam size measurements than the 5 micron slits. The only advantage the 1.8 micron slit has over the 5 micron slits for beams larger than 20 microns is that the 1.8 micron slits will provide profiles with more spatial resolution. How much power is in the beam? Once the size and power of the beam is known, check the NanoScan operating space charts to determine which NanoScan detector is best. Can a silicon NanoScan measure a 532 nanometer 10 milliwatt beam that is 1 millimeter in diameter? The coordinates of 10 milliwatts of power and 1000 microns fit inside the parallelogram of the operating space, so the silicon 95 NanoScan is a fit. If the beam is 10 watts instead of 10 milliwatts, it falls well above the operating space parallelogram. So the silicon NanoScan with 5 micron slits is not appropriate for this application. Instead, consider the pyroelectric NanoScan with 5 micron slits. A 5-watt beam at 1000 microns fits easily inside the operating space parallelogram for the pyroelectric NanoScan. If attenuation is applied to the 5-watt beam, the silicon NanoScan could be used. One of the strengths of the NanoScan is that for many applications, no beam attenuation is needed, greatly simplifying measurements. Is the beam continuous or pulsed? If the beam is continuous, there is nothing further to consider. If the beam is pulsed, careful NanoScan selection is required to be certain the beam is measured accurately. If the laser is pulsed, what is the repetition rate? The NanoScan considers each pulse as a data point in the profile. If the laser is pulsing rapidly, many data points are required to get a good profile. But if the laser is pulsing slowly, fewer data points will yield a profile of limited use. We recommend capturing at least 15 pulses or more in the NanoScan profile when operating in pulsed mode. Also, if the beam is small, a high density of points acquired at a higher repetition rate is needed to get a good profile. While if the beam is larger, the laser repetition rate can be slower and still acquire 15 points. Since there is a complicated relationship between beam size measured and repetition rate, check the pulse chart to help determine if the NanoScan is the right tool to measure a pulsed beam. For over 40 years, Ophir Spiricon has met the challenge to consistently provide accurate and reliable laser power and energy measurement and beam profiling solutions. Measuring your laser has never been easier. To discuss your application with a sales engineer, call 866-755-5499 or visit us on the web at ophiropt.com/photonics. Ophir Spiricon, the true measure of laser performance.